The sardine run of southern Africa occurs from May through July when billions of sardines or more specifically the southern African pilchard Sardinops sagax spawn in the cool waters of the Agulhas Bank and move northward along the east coast of South Africa. Their sheer numbers create a feeding frenzy along the coastline. The run, containing millions of individual sardines, occurs when a current of cold water heads north from the Agulhas Bank up to Mozambique where it then leaves the coastline and goes further east into the Indian Ocean. In terms of biomass, researchers estimate the sardine run could rival East Africa's great wildebeest migration. However, little is known of the phenomenon. It is believed that the water temperature has to drop below 21 degrees Celsius in order for the migration to take place. In 2003, the sardines failed to run for the third time in 23 years. While 2005 saw a good run, 2006 marked another non-run. The shoals are often more than 7 kilometers long, 1.5 kilometers wide and 30 meters deep and are clearly visible from spotter planes or from the surface. Sardines group together when they are threatened. This instinctual behavior is a defense mechanism, as lone individuals are more likely to be eaten than large groups. Causes of the sardine run. The sardine run is still poorly understood from an ecological point of view. There have been various hypotheses, sometimes contradictory, that try to explain why and how the run occurs. A recent interpretation of the causes is that the sardine run is most likely a seasonal reproductive migration of a genetically distinct subpopulation of sardine that moves along the coast from the eastern Agulhas Bank to the coast of KwaZulu-Natal in most years if not in every year. The migration is restricted to the inshore waters by the preference of sardine for cooler water and the strong and warm offshore Agulhas current, which flows in the opposite direction to the migration, and is strongest just off the continental shelf. A band of cooler coastal water and the occurrence of natal pulses and breakaway eddies make it possible for sardine shoals to overcome their habitat constraints. The importance of these enabling factors is greatest where the continental shelf is narrowest. The presence of eggs off the KwaZulu-Natal coast suggests that sardines stay there for several months and their return migration during late winter to spring is nearly always unnoticeable because it probably occurs at depths where the water is cooler than at the surface. In some years there does not appear to be a sardine run. This may be because it is not detected by coastal observers either because it actually does not occur due to high water temperatures and/or other hydrographic barriers, or the migration may occur farther offshore and possibly deeper due to unusual conditions. Oceanographic influences. Sardine prefer water temperatures between 14 and 20 degrees Celsius. Each southern winter the nearshore sea temperature along the South African southeast coast drops to within this range. Along the KwaZulu-Natal coast, sardine may be found in water warmer than 20 degrees Celsius. It was hypothesized that factors beside temperature may influence the movement of sardine along the KwaZulu-Natal coastline. One of these factors may be predation pressure. Oceanographic regions of the KwaZulu-Natal coast The KwaZulu-Natal coast includes varied oceanographic regions, each influenced by distinct environmental forces. The continental shelf waters of the KwaZulu-Natal mid to lower south coasts are dominated by the warm Agulhas current which flows toward the southwest. This water has a mean winter temperature of 23 degrees Celsius and the current speed is often more than 1 meter per second within 5 kilometers of the coast. The Agulhas current follows a very constant path. The main stream is just offshore of the continental shelf break most of the time, which suggests that conditions are normally unsuitable for sardines along that part of the coast. Local winds do not appear to have much effect on the currents. Sardine move closer to shore as they travel northwards along the coast, but it is not known whether this is due to environmental conditions or biological conditions. There is a persistent cyclonic gyre, known as the Durban eddy where warm Agulhas current water flows onto the shelf and the resulting inshore current direction is from south to north. This section of coast may be considered a transition from the wind-dominated section of the continental shelf to the north, to the Agulhas current-dominated section of shelf to the south. The north coast section of continental shelf is considerably wider than that of the south coast, roughly 15 kilometers. This causes the Agulhas current to flow farther offshore, and current conditions over the shelf are more variable. Wind appears to be a dominant influence in the region. Longshore northeasterly or southwesterly winds precede currents of similar direction by roughly 18 hours. Sea temperature is often lower and nutrients higher than along the south coast. The north coast would seem to be more suitable habitat for sardine, but it is not known to what extent they use it. These distinct regions may affect sardine distribution and movement. Oceanographic variables and sardine presence equals. Some oceanographic variables have been found useful for describing conditions influencing sardine presence. Water temperature has an inverse and highly significant influence. This is consistent with the preferred temperature range of sardine. Sea currents have a significant effect, with calm current conditions most favorable for sardine presence and moderate current speeds from north to south most detrimental. As sardine movement during the run is northwards, this counter-current effect is expected. Other conditions associated with sardine presence are, increasing atmospheric pressure. Sardine presence appears to be higher during periods between the cold fronts along the KwaZulu-Natal coast. These periods have calm atmospheric conditions and slow nearshore currents. Large swells and low water clarity associated with cold fronts have a negative effect on sardine presence. Wind direction, wind speed, current direction, air temperature and rainfall all significantly affect sea surface temperature and consequently sardine presence. Current and wind direction effects dominated, with northeasterly wind and currents from north to south resulting in cooler sea surface temperatures. Northeasterly winds cause the surface water layer to move away from shore, allowing the cool water to reach the surface, and southwesterly winds push warm Agulhas current surface water towards the shore causing inshore temperatures to increase, which would negatively impact upon sardine presence. Increasing maximum air temperature, southeasterly winds, wind speeds in excess of 6 meters per second, and rainfall, all result in warmer sea surface temperatures. Strong southeasterly winds and rainfall are associated with the passage of frontal systems, which would push warm surface waters short resulting in warmer sea surface temperatures. Frequent light northwesterly land breezes. When northwesterly land breezes are the strongest winds of the day they have a cooling effect on sea surface temperature. This cooling should be greatest in the vicinity of the surf zone where mixing is most effective. Sardine are often sighted close inshore during early mornings, suggesting that they could be attracted by cooler conditions found there. Summary: Oceanographic predictors of sardine presence, favorable, decreasing sea surface temperature, calm current conditions, light northwesterly land breezes, stable atmospheric conditions. Unfavorable, increasing sea surface temperature, moderate north to south currents, large swells, turbid water, northeasterly and northwesterly winds and north to south currents have a cooling effect upon nearshore sea surface temperatures, but southeasterly winds and increasing air temperatures cause nearshore sea surface temperature warming. Predators, dolphins, but also the bottle-nosed dolphin, are largely responsible for rounding up the sardines into bait balls. These bait balls can be 10–20 meters in diameter and extend to a depth of 10 meters. The bait balls are short-lived and seldom last longer than 10 minutes. Once the sardines are rounded up, sharks, game fish and birds take advantage of the opportunity. Cape fur seals follow the shoals up the eastern Cape coastline as far as Port St. John's. Predators as predictors of sardine presence equals, the Cape gannet is the predator species most closely associated with sardine presence along the eastern Cape and KwaZulu-Natal coastline and is the most useful indicator of sardine run activity. Sharks and large gammefish presence is also strongly associated with sardine presence during the run, but as they are not as easily observed from the surface they are not as useful a predictor of sardine presence. The presence of common dolphins inshore along the east coast during winter is significantly associated with sardine presence and common dolphin can be considered the third most useful species for predicting sardine presence. The resident population of bottle-nosed dolphin does not appear to associate with the sardine run, whereas the migrant stock does. This may explain why the bottle-nosed dolphin is less likely to predict sardine presence. Record of predators 2005 records. In June and July 2005 the avian and mammal predators included Bridie unregistered trademark S. whale, African penguin, Cape cormorant which were predominantly found in the cooler southern part of the region. Peak sardine run activity occurred within 4 kilometers of shore at the northward limit of a strip of cool water.